represent functions as graphs. So we've talked about what a function is. It's a set of numbers that are related from one to another, where you have an independent variable and then a dependent variable. Most often, when we set these up, there's going to be a y, and then on the other side there's going to be an x. There's going to be some other operations probably on the other side with the x side, but the x is going to be the independent variable and the y is going to be the dependent variable. And so if you look here, and again we have domains and ranges. The domains are going to be the x values and the ranges are going to be the y values. So it says here for the input for x is going to be 1, 2, and 4. The output is going to be 2, 3, and 5. So over here we have what we're going to do is we're going to move over to the left from the 0, 0 point. We always start at the 0, 0 point right there. And then we move over 1 and then up 2. That's why we end up there. That's that first point here. The second point is going to be, well, we're going to go over 2 and then up 3. So that's why that point there is going to be this one right there. And then the last one we're going to talk about here is 4 and 5. So it's over 4, 4 on the bottom, and then 5 up. That's how you end up with that right there. So in terms of graphing a function, the example is right here. It says here, graph the function y is equal to 1/2 x, or 1/2 times x, with the domains 0, 2, 4, 6, and 8. So it's really important that you understand that this is what we're graphing. Y is equal to 1/2 times x. So then we're just going to plug in the values of x into there that we have here, and the values for x here. We can set up this chart, and then we can just fill in the corresponding things. So if I put 0 right in there where the x value is, it's going to be 1/2 times 0. That's why I end up with a 0 there. If I put 2 there, I'm going to end up with 1/2 times 2, and that's why I end up with 1 for the value for y. And the same thing happens for x is equal to 4. Then I'm going to end up with 2. X equal to 6. I'm going to end up with 3 for the value for y, and x is equal to 8. The value for y is going to be 4. And then same way as I did it up here, I'm going to do down here. So I'm just going to move over from the origin. Again, that's the starting point. Always going to be the starting point, 0, 0. Going to go over 2 and up 1. That's why I end up with that first point there. Then over 4 and up 2. Then over 6 and up 3. And then over 8 and up 4. And I nearly forgot that first point, which is going to be 0, 0. So now we're going to do another one of these. So we have to draw this out a little bit. It says here, graph the function y is equal to 2x minus 1 with their domain 1, 2, 3, 4, and 5. So I'm going to come up with a chart here. So let's x and y. And remember, I'm going to do 1, 2, 3, 4, and 5. And then I like to write out over here just in a little bit bigger letters here, 2x, because this is what I'm plugging it into. So y is equal to 2x minus 1. Well, when x is equal to 1, what's y going to be? 2x times 1 is going to be 2 minus 1 is 1. Then for the value for x is 2, that's going to be 2 times 2, 4 minus 1 is 3. For the value for 3 for x, it's going to be 2 times 3 is 6, minus 1 is 5. For the value for 4 for x, it's going to be 2 times 4 is 8, minus 1 is 7. And the last one, for the value for 5 for x, it's going to be 2 times 5 is 10, minus 1 is going to be 9. And so now I'm just going to plot these points. I have to make sure I have enough room here. So the x, 1, 2, 3, 4, 5, 6, 7, it's more than enough. And then I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Made this a little bit smaller because I need to make sure that I have enough room. I'm going to label this just to make sure I got this right. So 2, 4, 6, 8, and the top one's going to be 9. This is 2, 4, and 6. So now I'm just going to plot the points. 1, 1 is going to be right there. I should probably label this as 0. 0 for both. So 1, 1 is going to be right there. 2, 3, 2 over 3 up is going to be right about there. So that's the second point there. So 3 over 5 up, go to 3 and then 5 up, so it's going to be right about there. 4 over and 7 up, 4 over and 7 up is going to be right about there. And then 5 over and 9 up, it's going to be right about there. And so you see a nice straight line. So now this next one, it's going to talk about SATs. I'm going to just read this problem. It says here that the table shows the average score S on the mathematics section of the Scholastic Aptitude Test in the United States from 1997 to 2003 as a function of time in years since 1997. In the table, 0 corresponds to the year 1997, 1 corresponds to 1998, and so on. Graph the function. So we've got the data right here, and we just have to figure out what the divisions are going to be and how we're going to write this up. So since we're going to start with 0 year being 1990, well, it's 1997, it's going to be the 0 year. When we go up, the second year will be 1998, 1999, and so on. So the x values, the x values are, or what would be the x values, the horizontal values, in this case here it's t, are going to range from 0 to 6, because that's the amount of years there are. The y values, they're going to range from 511 to 518, so it's important to figure out how you're going to put that together to make it so you can read it on a graph. And the way you do this is you go ahead and you figure out what the divisions are, and you add this thing called a break in the graph, because you're going to jump up to the 500s very rapidly, but you want to be able to show the data still. So that's something to pay attention to. If you see that, you know that there's a break in the graph. So it goes up to 510, then 514, and then 518. And then all we're doing is we're just graphing each of these points down there. But it's important to realize how you would set that up with the divisions. That's kind of the key part of this lesson, how you would do that part right there, because you want to make it so it's easy to see the data, but that there is some difference to it there. And what would happen if you were to take the axis with the score, the s-axis, from 0 to 520 in increments of 1 unit? Well, let's see here. If that was the case, what it would look like instead would be this. So we got our regular units down there. This is going to be the time. And then S is over here, but 4, 5, 6, 7, 8, 9, 10. So I've only gotten to 10. Imagine how big the graph would have to be to get to 500, and even more than that. So now we're going to get into how you actually determine what functions are based on a graph. So it says here, write a rule for the function represented by the graph. Identify the domain and the range of the function. Well, first of all, we can represent the data in the range. That's just, if we wanted to go the domain and range very quickly, would just be 1, 2, 3, 4, and 5 for the domain, and the range is going to be 2, 3, 4, 5, and 6. That information I'm taking directly from this graph, because all I'm doing is I'm taking the points, the x, how far it went left, or excuse me, how far it went right on the graph to get up to this point here, and then how far it went up, and then so on with this. So for this first one here, it's going to be 1 over and 2 up. For the second one, it's going to be 2 over and 3 up. This is going to be 3 over and 4 up, and 4 over and 5 up, and then 5 over and 6 up. So that's how you determine that. And then what you're looking for is you're looking for the pattern, and what you can probably figure out is just that when you're trying to relate the x and the y together, you can see that y, we always start with the y on one side, it's just something to get used to, is equal to x plus 1. Because each time x goes up by 1, y goes up by 1, but it starts at 1. So that's important to realize. So next, last part here, this is probably the most complicated thing in terms of this, so this is really important to pay attention to. It says here, write a rule for, in terms of guided practice, write a rule for the function represented by the graph, and identify the domains and the ranges, the range of the functions. So I just took the data and read it and changed it into a chart from there. And so now what I'm trying to do is I'm trying to relate the x and the y together. And the way I like to do this is I like to write out an equation. So y is equal to x. And then I'm trying to make y equal to x. And what do I have to do for that first one? If x is going to be equal to 0, well, if x is 0, and then I have also, let me do this again, if I know this here, 5 for this first point here is equal to 0, what do I have to do on that right side to make it so that that's a true statement? It's going to be plus 5. So in order to do that, I have to change that up there. So now x plus 5 works for this first one, this first part right here. So x plus 5 works for that 0 and 5 pair. But now I'm going to try and plug in here 1 and 4. And in that case there, I've got, well, 4 is equal to 1 plus, and then 1, 5, because I've got to use this part here down there as well. And when I plug that in, that isn't right. So I now know, that this part of the equation is right. I can't change that part, but I know I need to get it so that this goes down. So what instead I'm going to do is I'm going to subtract 1, because -1 plus 5 equals 4. And then I'm going to plug that in and see if it works. The way I have to do that, though, is I have to change this sign here to -1x plus 5. And that's just that. We'll do a few more of these because this is probably pretty complicated. But then I plug in and check the answer here for when x is equal to 4, -1 times 4 plus 5. Is that going to be equal to 1? Yes, it actually is. So I then know that I'm on the right track. Let me do another one of these. The key thing to understand is that you've got to figure out this part here. That's where it crosses the 0 line, or the 0 line for x. So when it crosses the 0 line for x, that's going to be that number. And then this other part that's in front here, that's going to be the thing that determines how it goes up or down. So let's do one more. So I'm going to write out now for this one here what the actual numbers are. Okay, so that's the data. Those are the ordered pairs for this one right here. So now I've got to figure out how to relate those two together. And just like if you remember what I just said about how where the x-axis, or where the x value is 0, that's what's going to be this part of the equation. This part right here, that's the question mark. That's what's going to go there. I don't have a 0 part, I don't have a 0 point here, but I can figure out the 0 point either by looking at the graph and just figuring it's going to go there, or by putting in 0 and saying, well, from 2 to 1, it went down 5. From 3 to 2, it went down 5. So I bet it goes down 5 from 1 to 0. So it's going to be 5 here. So this, now I've got half of the problem done. So it's going to be x plus 5. This is now a true statement for this one right here, but it is not true yet for this part here. So now I have to figure out what am I going to do. And the easiest way of doing this is by looking how much it goes up by each time. In this case here it goes up by 5 each time. That's what makes it so that it is, in this case here it doesn't go up by 5, but that's what makes it so that there's a 5 in front here. It's called a coefficient. And then we plug in the numbers and we see if it works. And so let's plug in 3 and 20 and see if it works. Does 20 equal 5 times 3 plus 5? It sure does. So it looks like we've got our answer right. And I can probably do another one just to make sure. 10, I'm going to do it with 1. Is that equal to 5 times 1 plus 5? I just went ahead and plugged in this. It's always a good idea to check your answers a couple of times. And so then I know I've got the right equation. A lot of this is about puzzles and trying to figure out how it works. And actually, it's really interesting to see how you can do this. So now what we're going to do is we're going to look here at a graph of guitar sales. It says here, this graph shows guitar sales in millions of dollars for a chain of music stores for the period 1999 to 2005. Identify the independent variable and the dependent variable. Describe how sales changed over the period and how you would expect sales in 2006 to compare to sales in 2005. Well, we have the data. We're looking for where it would be with this one right here. This next line over, that's what's going to be 2006. So we're going to look at the data here, and it's going up here. First of all, the independent variable is going to be the years. The dependent variable is going to be the sales. And now we just have to kind of look at that trend and see what happens. It looks like it's probably going to be like around there. And then we read the graph closely, and we can see that that's a little bit below 1.4, but we would expect it to continue to go up. So now it says here, based on the graph and example 4, is 1.4 million a reasonable prediction of the chain sales in 2006? Explain. Well, it's pretty close. I would say it's a pretty good estimate. Not exact, but pretty close.